Hello everyone and welcome to a new Sega Mega Drive and Genesis game dev tutorial. In this lesson we're going to learn how to do more parallax scrolling. Now I already did a episode on parallax scrolling quite a while back, but that was for two layers which are scrolling automatically, and in the last lesson we did a tutorial on how to create your own camera so that it follows the player around a very big level map. Combining that with a parallax background is a bit more tricky than what we did before, but thankfully this is going to be a lot shorter lesson than the camera one, which was over 40 minutes. In order to demonstrate this technique, I thought it'd be fun to combine assets from three of my favourite Mega Drive games. I'm sure most of you probably know what those three games are, but let's take a look at the assets we'll be using and how they play into the code. So here is the level map we'll be using, and it uses 16 colours and the colour mode is index, plus is the length and the verticality is a multiple of 8, so just remember that when you're doing your own one. And I'm sure you've all guessed which game it's from. It's from Revenge of Shinobi. Now in the original it actually doesn't have much verticality, it just goes 224 pixels, but three of those tiles at the top are taken up by the HUD, so that's why the bamboo shoots cut off 3 tiles from the top. Now because in this tutorial I want to demonstrate how to scroll vertically as well as horizontally, I've just added quite a few tiles at the top, so it makes it a lot bigger. So it's actually 352 is how high it is vertically, and the horizontal side is 6176. I didn't try to recreate the level, I just ripped the assets from the first screen and I just randomly copied and pasted the assets until we get all the way to the end where I kind of gave up, and I thought, okay, that's long enough, let's stop here. The far background we'll be combining that foreground with is from Shinobi 3, and the verticality of this is even shorter. It's only 136 in terms of how high it is vertically, so I've added some tiles to the bottom and to the top. I think it was the very first lesson, or one of the first lessons I did on the channel, where we put the backgrounds on the screen, and if you recall from that, the largest background you can have, the largest size, is 512 pixels horizontally by 256 vertically, and that's exactly the size of background we have here. The screen size we're going to be using is 320 by 224, so that gives it lots of space to scroll, and the scroll will be repeated. But some games, they actually only have a single background that takes up one screen and there's no scrolling. So for example, Castlevania Bloodlines, this background is 320 by 224 and there's no scrolling at all, it just stays stationary and it's the foreground that scrolls. That's an option if you want to do so, but I think generally it's better to have a scrolling background. I think it looks nicer. This will be the starting off point for our coding today. I've just pretty much carried on from use the code we created in our camera tutorial, but obviously I've changed the background and so on. The reason the sky is black here rather than pink in the image I showed you of the foreground is because we're using PAL 1 here for the colors, for the palette of the foreground, and remember that PAL 0 is the first palette and PAL 1 is the second, and the first color of the second, third and fourth palettes are always transparent, so that pink is actually just a transparent color, it doesn't turn up on the screen, and where it's black here is where eventually our background's going to show up. As for the starting code itself, obviously in resources.res I've had to change things to reflect the new assets we're using, and we've also made some changes of course to the map size, so we have to change the constants here, the values in there, and not only the width and the height, but also of course the player width and height, because the sprite we're using has changed. It's not Link anymore, it's the dog from Shadow Dancer. At the very end of the previous tutorial on the camera, I mentioned that we can probably replace a lot of the ints we're using, that data type, the 32-bit numbers, with S16, the signed 16-bit number, because S16 it can cover numbers all the way from minus 32,000 to positive 32,000, and that should be enough for any map we want to create really. The map today is only 6,000, so that's well within that limit. So as I said, using a 16-bit number is better than using a 32-bit number. It's easy on the CPU, it uses less ROM too. So in this code here I've made a slight change where I've gone through all the ints we were using, the 32-bit numbers, the INT data types, and I've changed it to S16, and the code is working fine. So long as you're using maps under 32,000, then you can go ahead and you can change all those ints to S16s. The only other change I've made to our camera code here is purely a cosmetic one, and that is to do with the if and the else if statements. Previously, when writing an if statement, for example, we had the if word, and then we had the regular brackets, and then whatever was in the regular brackets, that was a condition, and if it proved true, then we'll do whatever code is in the curly brackets afterwards. And I'm just changing it back to the way it was as we did it last lesson. So we got the if, then if it happens, then do whatever's in the curly brackets. But in circumstances where the curly brackets only contain one line of code, only one thing happens, in that case you can actually get rid of the curly brackets and just have it on a single line if you want, and it just looks a bit neater that way. As I said, it's purely a cosmetic change, and I've also done that with the rest of the code in the camera function, where we had any if or else if statements where just one thing happened if the statement in the first brackets proved to be true. If we scroll down a little more, you'll see an area where I couldn't do this, and that's this particular if statement here, because there are 3 lines of code, 3 separate things that happen if the statement is true. So I couldn't get rid of the curly brackets, so I had to keep the curly brackets there. You can make these changes if you like, but as I said, it's purely cosmetic. In terms of the D-pad controls, I left the curly brackets in because often with D-pad controls, you want more than one thing to happen if they, for example, move left or right. For example, you might want to change the animation, or you might want to flip the sprite from left to right. So in general, it's probably a good idea. If you think you're going to add stuff in the future, then just leave the curly brackets in place. With that all out of the way, let's start writing some new code. The first order of business will be to add our image to the ROM. So in the resources in the res folder, I've already added our image, and in the resources.res, we simply write this line of code to add the background image. We've studied this in a previous lesson, so this is just a reminder of how to do it. With that saved and compiled and the image now on our ROM, the next step is to set up our code in main.c so that the background image displays on the screen. Firstly, we're going to set up the palette, so we're going to assign the palette from the image to pal0, which is the first palette. And to do that, I'm sure you remember we just used the name of that we gave the file. We do .palette, then -arrow data. You can see here the code where we put the foreground map on the screen. We set it to BGA, which is of course the foreground, and we're going to set the image to BGB. We already covered in all this code in how to display background, so I'll just go through it very quickly here. We do VDP_, and we need to pick draw image X, and then we open the brackets, and then it's going to ask us which plane we want to use. It's BGB, which is the far back plane. And then it's going to ask us which image we need to use. Don't forget the and symbol before you put the image name, the name we gave the image. And then next we do tile attrib full, and then we fill in the rest as usual, just pal0, and all the priority and flip vertically or horizontally we all set to false. And then just finish off the rest of the data as well, and we'll be done. If we save and compile, this will be the result. So you can see that the foreground is scrolling as normal and the background is displayed successfully. All the colors look fine, but it's not moving at all. This would be fine if you want to use one of those Castlevania Bloodlines backgrounds, which are only 320 by 224 and where they're not meant to scroll. But of course, the point of today's lesson is to teach you how to scroll these backgrounds. So let's do that now. Just as we did with the parallax scrolling lesson, we're going to do VDP_set scroll mode. So when we set the scrolling mode, we're going to choose how it scrolls horizontally and vertically. Of course, we have tile scrolling and line scrolling, but we're just going to choose basic plane scrolling today. So the whole plane's going to move. So that's h_scroll_plane and v_scroll_plane. And of course, don't forget the semicolon. We then need to scroll down to our camera function, because that's where we're going to put the actual scrolling code for the background, right where we put the scrolling code for the foreground. As is often the case, we will begin this process by creating a couple of variables where we're going to store the background scrolling figures. I'm going to call the first one b_h_scroll for the horizontal scroll, and just like with the other variables, I'm making this a signed 16-bit number, which will allow numbers from minus 32,000 to plus 32,000, which would be more than enough. We can probably make this even an 8-bit number, but let's keep this a 16-bit number for now. I've also created one for the vertical scrolling, and now we have to actually scroll. So remember from the parallax scrolling lesson, we can do VDP underscore set horizontal scroll. So this is where we're going to determine how far it's going to scroll horizontally. We choose the background we want to apply this to, and that will be BGB in this case. And then we're going to set the value. So we're simply going to set the value to H scroll. And of course, we're going to do the same for the vertical scrolling now too. Okay, so we're pretty much done in terms of doing the scrolling code for the background, but of course we've set these the scrolling for both horizontal and the vertical scroll for our background as the two variables we just created, but we haven't actually assigned any values to these variables. To begin with, let's just set these values as the same as the new camera values that we set for our foreground. So we're going to make b underscore h scroll, we're going to make it equal to the new camera x, and we're going to make b v scroll equal to the new camera y. So these are the scrolling values, the camera coordinates that we gave our foreground. So let's do that, let's save and compile, and let's see what kind of result we get. As we scroll our canine friend up and down, the effect is probably as you expected. They're both moving at the same speed, so there's no kind of parallax going on. It almost looks like it's one single background, so that's just as we expected. But what if we move it horizontally? What do you think would happen then? So this is probably different from what you expected. They're both moving, but they're moving in opposite directions. So the effect is quite funky. There was that game, I can't remember the name, where the parallax was going opposite to what it should have done. I think it's called Gym Power or something, and so that makes you feel a bit sick, and it's making me feel a bit sick here just scrolling, because it's a very unnatural way of the background moving. It's almost like in VR we can get a bit sick with so let's end that now and let's see if we can fix this. Since the background appears to be moving in the opposite direction that we wanted to, the obvious fix is to simply multiply the new camera x, which we're assigning to the BH scroll, by -1, and that should make it negative, which should make it scroll in the opposite direction it was before. And if we load it up and compile, we can see that now it's scrolling okay, they're scrolling in the correct direction. Again, like with the vertical scrolling, because they're scrolling at the same speed, it looks almost like one single background. Well, this simple fix has solved that problem. There is one issue with it, and that's that the Mega Drive CPU is not very fast when it comes to multiplication or division. So we want to think of another way of doing it, and an obvious way is to do 0 minus new camera.x and then assign that value to the BH scroll. And when saving, compiling, loading up the emulator again, you can see that the effect is the same, but we've used a subtraction rather than a multiplication, which is much easier on the CPU. Not that it matters too much at this stage, because we're not doing very much with the code, but if you've got lots of collision code and enemy AI and so on, then it could potentially slow it down. So it's a good habit to not use multiplication unless you absolutely have to. If you have another way, then choose the other way. Since the mountains and forests of our background are further away than the foreground, it's only natural that they should scroll more slowly, so that's what we're going to do now to achieve a bit more depth for parallax effect. And the obvious choice is simply to divide the number by 2. So whatever new camera is, x is, we make it negative and then we divide it by 2, and that should make it run at half the speed of the foreground. Looking at the newly compiled ROM here, it looks like we were successful, so it looks a lot more natural now. The scene, we have some parallax scrolling. The mountains are going more slowly. Of course, we can adjust this. We can do it divide by 3, for example, and it should move even more slowly. I think the dividing by 3 is looking better than dividing by 2, because the mountains and trees should be far away. Of course, we can also try different values, for example divided by 8, where it'll be even more slowly, and it's up to you which one you choose. Of course, if you have a background that's much closer to the foreground, for example some buildings just behind, then it should move a bit quicker, whereas if it's something very far away, for example these mountains, then obviously they should move a bit more slowly, but the choice is yours. Well, that is all working fine. As I said before, the Mega Drive CPU is not so fast when it comes to doing multiplications or divisions, so let's think of a better way we can do this that gives less strain to the CPU. The way we can do this is to use a method called bit shifting, where we shift all the bits either to the left or to the right. So if we use these two arrows here, it means we're going, and we put the number 1, it means we're going to take this number, the 0 minus new camera X, and we're going to shift all the bits, the 0s and 1s, we're going to shift them to the right by 1 place. If we do shift all the bits to the right by 1 place, it means we're going to actually divide that number by 2. If we shift all the bytes by 2 places, then it'll divide by 4. If we shift them all by 3 places, it'll be divided by 8. And if we shift them all 4 places, it'll be divided by 16. If you're curious about why this is the case in terms of the computer science, then I will link this video in the video description. While it's not strictly necessary to understand this, I definitely recommend that you give the video a watch. If you'd like a quick analogy, then I suppose you can compare it to how as humans we find for example, our brain finds the 10 times table much easier to compute than the 7 times table, which requires a bit more brain power. For the Mega Drive CPU, which uses binary, it finds it much easier to multiply and divide by numbers which are powers of 2, so 2, 4, 8, 16, 32 and so on. If we head back to our code and we bit shift the horizontal scrolling to the right by 1 place, then you can see when we load up our ROM that the background is scrolling at half the speed of the foreground. And if we do bit shift by 2 spaces, you should see that it's moving at a quarter of the speed, so it's dividing by 4. For this particular background, I personally think that bit shifting by 3 places would be best, so that will be dividing it by 8, so that would mean that the background moves at 1/8 of the speed of the foreground. I think given how far away the mountains and the forest are, then I think that's the best way. And just to demonstrate here, if I do divide by 8 instead and then save and compile this, you should see that the speed is the same as when we did the 3 bit shifts to the right. Okay, let's change that back to the bit shifts, and now we're going to focus on the vertical scrolling. Let's also bit shift that to the right 3 times and see how it looks. You can see that they're not scrolling together now vertically. It's moving, the background scrolling is moving at 1/8 of the speed of the foreground. That's already looking a lot better, but let's change the speed now so it moves at half the speed of the foreground, and that's going to expose a little problem. So if we load this up here, if you look at the very bottom of the screen, you can see just at the bottom there where that brown part is where the vertical scrolling is repeating the background from the top. So it gets down to the bottom, which is this green color, and it gets to the top, which is this more browny color. If I quickly replace the Shinobi 3 background with this Sonic background, you'll see it much more obviously, where just like when we scroll horizontally, if you scroll past a certain point, then the background will repeat again, and it happens vertically too. So you can see that the clouds and the sky starts to repeat, and well, that might be fine for say a vertical shooter. For doing a side scrolling platform game, normally you don't want this to happen. So next I'm going to show you how to write some code to prevent this. The method is actually going to be very similar to how we stopped the camera from overshooting the map in the last lesson. We're going to create an if statement where if the vertical scroll, if it's less than 0, then we're going to make it equal to 0. And we're also going to add an else if statement, whereas if the vertical scroll is greater than a certain number, then we're going to make it equal to that certain number. I want you all to think for a moment which figure we should put into this else if statement. The answer is actually 32, and in a moment after I finish writing this, we're going to take a look at our background image to see why this is the case. As you all know by now, the very top of the image, the Y coordinate for that is 0, and then it increases as we go down. So we've already set the code so it can't go past 0, can't be less than 0, but how far do we need to let it scroll downwards before we can stop it, and why is it 32? Remember that the size of the screen is 224 in the vertical direction. So if we pretty much take the 256 minus the 224, we're left with 4 tiles left over, and those 4 tiles of course equal 32. So it can scroll down by 32. Once it goes over 32, it's going to start to repeat vertically. So that's why we need to set the limit to 32. If we head back to our ROM now and take a look, we'll see that that issue is now fixed. However much up and down we go, the vertical scrolling is not going to, the background is not going to start to repeat vertically. It's just going to repeat horizontally as we keep scrolling left or right. Actually, regarding the code we just wrote, I think that we could probably get rid of the very first line where we made it so that if the top, if it's less than 0, then we make it equal to 0, because I'm pretty sure that we already did that when we did the foreground scrolling. So we made that the y value of that, we made sure it didn't go past 0, didn't go below 0, and since we're using that variable for our scrolling here, then it should be unnecessary, but we'll keep it anyway. In this lesson, I've taught you how to combine a foreground map, level map, with a background image. Now we could potentially use two maps and we can put them on top of each other and we can scroll it that way, but 90% of the time, or 95% of the time, you're going to be using a map resource with a regular image for the background. There are a few reasons for this. So one of the reasons is with an image background you can do stuff like tile scrolling, both vertical and horizontal, and you can also do line scrolling too, so you can do all these kind of fancy scrolling effects, and those aren't available when you use the map resource. Another even more obvious reason is the fact that the reason you need a big map for the background, a non-repeating map, is because obviously that determines the gameplay, what kind of obstacles you need to avoid and platforms and so on, whereas the background is purely cosmetic. It's just meant to be, it doesn't really affect the gameplay, it's just there to look nice, and normally for that just a regular image, a 512 by a 256 image that repeats over and over is enough. You don't need it to be constantly changing all the time. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.